This is the lesson for Friday, October 8th. It goes from page 15 to 19, but it's going to be broken up into two parts. Right now, please open your math packet to page 15 and hit the pause button after answering the question, what can you determine from the equation 3 times 1/4 to the x power? And as you're trying to figure out what you can determine, you'll have to graph this function and give the characteristics domain, range, intercept, y-intercept, and asymptote. As you can notice from what I labeled the equation with, I've labeled A and I've labeled B. A is the initial value, otherwise known as the y-intercept, and V is the growth or decay factor. I know that this is a decay factor because it happens to be a fraction between 0 and 1. Therefore, it is a decreasing function. This equation should be read as starting at the number 3, keep multiplying by 1/4. So, since we already know what the y-intercept is, it's a good idea to try to get a point before the y-intercept and a point after the y-intercept, in which case I've come up with a table where I've chosen -1, which is before x is 0, where the y-intercept is, and x equals 1. When I plug those in, especially the first point, -1, it's 3 times 1/4 to the -1 power. -1 flips the fraction from 1/4 to 4/1. 3 times 4 is 12. And then notice in the y column on my table, I'm always multiplying by 1/4 to get to the next y value. And in fact, when I do x as 1, and I plug that in, I get 3/4. But if I had multiplied each of the y values by 1/4, 12 times 1/4 is 3, 3 times 1/4 is 3/4. I have enough points to create my graph. Now, exponentials always have a horizontal asymptote, which I drew here in pink. I don't know why this is up here. Doesn't look like I can move it. My -infinity for x and part of my asymptote is here, but really what I'm looking at is my asymptote here on the x-axis. So when I draw my function, I'm going to be doing a decreasing function that hits all 3 points and skims along the x-axis. Now that I have a graph, I can start answering the questions below. The domain of every exponential function is all real numbers. It extends from -infinity to +infinity. The range is based on that horizontal asymptote. If the horizontal asymptote is at y equals 0, then my range is going to be all y values greater than 0, because no part of our curve is going to touch that asymptote. And as we already described, the y-intercept is where x is 0. We get the 3 from the equation as that a value in the equation. That 3 is the y-intercept. The y-intercept is 0, 3. On to page 17. 17 on top of the page asks, what type of function models bacterial growth? What is the explicit formula that can be used? So what we notice is we're given 2 graphs, colony A of bacteria, colony B of bacteria, and there is no equation given at all, much less an explicit equation. An explicit equation is any equation or formula or function that is solve for y. So it's always a y equals equation, and we don't know what the equation is. We know it's going to be in this form because we know it's exponential growth. That's what we're studying. So our questions regarding colony A and B are, what are the unknowns in the formula? So I'm looking at colony A, that graph, and colony B. And I notice that information from colony A includes the A value, which is the starting value, otherwise known as the y-intercept. For colony B, what I'm missing is I'm missing the A value, I'm missing the growth value, I'm missing a lot. So I don't have what the multiplier is between the y values, and in the B graph I don't have the A value. The next part of the question is asking what information helps me figure out what that explicit equation is. So if I look at my graphs, again, I can see that colony A gives me the y-intercept or the A value 4, and both graphs give me 2 points to work with. So on the next page, page 18, we're going to discuss how to use the 2 points to find the explicit equation y equals, and we're going to fill in the A and the B value. And remember, every equation has both a y and an x, so the equation will still have a y and an x. On page 18, on the top, they give us the same 2 graphs with the same 2 points, and I point out down here that from this information from the graph, our x value in the equation is going to represent time, and y is going to equal the number of bacteria in hundreds as we create our explicit equation. So in colony A, you're going to do this in 4 or 5 steps. Your first step is going to be, sorry, I keep hitting the wrong thing on there. Okay, so my first step is going to be set up my table for creating points that will help me find the equation. And if you look at my table for colony A, I have x and y. The points I'm given is 0, 4. A is our y-intercept or the A value or initial value in our equation. At x equals 6, they give me the point 2,916. And I'm going to use both of those points to create an equation to solve for the missing variable. So since 4 gives us the initial value, 4 goes in as A into my exponential equation. I'm going to set that equation for y equal to 2,916, which I got from the other point in the graph. And now what I'm going to do is notice all of this space in between the 2 points. There's all of this space where I don't have x, y values. I only have x values. So what I'm going to do is count how many times I'm multiplying by the growth factor. So you can see as I go from 0 to 1, 1 to 2, 2 to 3, 3 to 4, and then 4 to 5, and 5 to 6, I am multiplying by B 6 times. So I'm going to multiply by that growth factor 6 times to go from 4 to get to 2,916. So that 6 times that I am multiplying by that growth factor, these 6 are represented by the 6 as the exponent. So look at the equation carefully. I started with y equals a times b to the x power. I'm using 2,916 for y. I'm substituting 6 for x because That's how many times I'm multiplying to get from 0 to 6. And I'm going to use the y-intercept or initial value of 4. Notice I only have one variable left now in the equation, and that's b. And I'm going to use my solving or inverses to find out what the b value is. This is what I mean by using my inverses. First of all, I'm going to undo the 4 by dividing both sides of the equation by 4. When I do that, I end up with 729 equals b to the 6th. To undo an exponential of 6, a power of 6, I am going to take the 6th root of b to the 6th to get b by itself, because remember, a 6th root undoes a 6th power. If I take the 6th root of the right side of the equation, I must take the 6th root of the left side of the equation. And then I have a very large number and I'm not allowed to use my calculator. So I have to come up with ways of figuring out what is the 6th root of 729. And here's what I recommend. I recommend that you do a prime factorization tree. Figure out what 729 can be divided by. It could be 2, it could be 3, it could be 5, it could be 10, and whatever that number is, I should be able to divide that number into 729 6 times, because that's what the 6th root is. What number times itself 6 times equals 729? Well, the number ends up being 3. 729 divided by 3 is 243, divided by 3 is 81, divided by 3 is 27, divided by 3 is 9, and then 9 is 3 times 3. If you look over here, I have multiplied 3 6 times. And so that makes the 6th root of 729, that makes the answer to be 3. Now, once I have the a value, which was already a given from the graph, and the b value, which I solved for, I have the information I need to create the equation. So notice, if I test my multiplier of 3, you can see 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. 108 times 3 is 324. 324 times 3 is 972. And then look, after multiplying 3 6 times, I get back to 2,916. So now I'm just filling in my a and my b for my exponential growth equation. 4 was our a value, or initial value, otherwise known as our y-intercept, and the b that I solved for previously, that goes into my equation as well. So the steps are the same. Create your table, figure out what's missing, figure out how many times you're multiplying by, in this case, the growth factor. Set up your equation using the 2 points you're given, and then use that to find the a value and the b value in your explicit equation. Colony B. For this one, I'm not given an a value, so I have to treat the point 212 as if it were an a value. Because to get from 212, that's this point here, to get from here to here, I'm counting how many times I am multiplying by b. I am multiplying by b 6 times again. So from 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, I am multiplying by 6 b's. So now I'm going to use 2, 12, and 8, 768 to create my equation so that I can once again solve for b. You're going to treat 12 as if it were the a value. Is this the a value in our final formula, in our final explicit equation? No, it's not. Am I using it as a tool to find out what the growth value is? Yes, I am. Use 12 as a, use 768 as your y value, and as we said before, you are multiplying by b 6 times, that's your exponent. Use what you know about inverses to undo the exponential, or now it's really a power equation, to undo that equation to solve for b. First step, divide each side by 12 so I can get b to the 6th by itself. To undo b to the 6th, I have to take the 6th root. Whatever I do to one side of the equation, I must also do to the left side of the equation. So if I'm taking the 6th root of b to the 6th, I am taking the 6th root of 64. 64 is from 768 divided by 12. And again, you're going to need a factor tree to figure out what multiplied by itself 6 times equals 64. So let's see if I can find my factor tree. Here it is. 64 divided by 2 is 32. 32 divided by 2 is 16. 16 by 2 is 8. 8 divided by 2 is 4. And 4 is 2 times 2. So I've got 1, 2, 3, 4, 5, 6 2's multiplied by each other. Therefore, the 6th root of 64 is 2. That is my b value. Now, our colony b is different because I did not have what the y value is when x is 0. So rather than multiplying by 2 to go from 0 to 2 for x and 3, or I don't know what it is for the y value is for 0, but rather than going forward, meaning adding or multiplying numbers, I'm going to have to use 1, 6 or 2, 12 to go backwards. So if I'm multiplying by 2 to get the next number, so when x is 3, 12 times 2 is 24, I'm going backwards. 12 divided by 2 is 6, so 1 point on my table and my graph is 1 comma 6. And then I'm going to divide by 2 again. This is going to give me the true a value, not the 12 I used to solve for b equals to 2. The true initial value is 3 because 12 divided by 2 is 6, so 1 point is 1 6. 6 divided by 2 is 3, so my true a value is 3. And now I have all of the information I need to fill in for my explicit equation. Y equals a is 3. B is the growth value of 2. So this is going to be your final answer for colony B. The last page we're going to do is page 19. I will not be going over the homework because the homework is on page 21. It's exactly like page 19. So any techniques that we use to do page 18 and any techniques I'm going to use now to do page 19 should be used to do page 21. When you do page 21, you still need to check your answers on Google Drive, and you need to annotate in a different color pen or pencil for mistakes you made, because as we already know, correcting our mistakes in math is how we make practice permanent. So I want you to please hit pause and try to complete 1 through 6 before the bell. I suggest you work with an elbow partner. That means with a substitute there, I do not expect you to roam around the room to find somebody you prefer working with. Work with somebody near your desk. So pause your video here and then try the problems a little bit before the bell, and then you can watch the rest of this video. I said I was going to do it on a separate video, but I think I'm just going to continue going here. So number 1 and 2 are quite easy because they give us both the A and we just have to calculate the B value. So here's the A value. The definition of the initial value or y-intercept is where x is 0. X is 0, then y is -3. -3 is substituted into your equation for the A value. And now to go from 0 to 1, I just have to figure out what I multiply -3 by in order to get -6. That's times 2. So our B value is a growth factor of 2, which means every value of y is going to be multiplied by 2 to get the next y value. That B goes into your equation for B, and I am done with number 1. Same thing happens with number 2. I can see that it's -1. That point occurs before 0, 4, but it doesn't matter. They're giving me the A value. The A value is 4, goes straight into the equation. And then the question becomes, how did I go from 4 to 0.4? 0.4 is the same as 2 over 10. So if 0.4 is the same as 2 over 10, to go from -1, to get from 0.4 or 2 over 10 to 4, I am going to be multiplying by, oh, I'm sorry, it's not 2 over 10. Oh, I'm so silly. It's 4 over 10, my bad. 4 over 10. To get from 4 over 10 to 4, I am multiplying by 10. So I'm multiplying every y value by 10 to get the next y value. I'm going to use that B value, that multiplier of 10 in my explicit equation. So my equation becomes y equals 4 times 10 to the x power. Remember, every equation, whether it's exponential, power, radical, rational, line, quadratic, always has a y and an x in it. Number 3 and 4 are a little more complicated. For this one, we're going to have to use a technique like we used on page 18, where we are given points and we are not given the A value. So we're going to have to use the point given 1, 2, specifically 2, to figure out how we're going to come up with our growth value as well as how we're going to come up with our A value, initial value. So I made a table, an XY table, as I've done for almost all of these, and I've put 1 and 2 and 1, and the 2 is the Y value, and 2 and 20. So what I did was, first I computed the B value. To go from 2 to 20, I am multiplying by 10. So 10 is my B value. It goes into your equation, and that 10 is raised to your X value because all equations have an X and a Y in it. Now, to find out how I get the A value, rather than go forward on my table from 1 to 2 for X and 2 to 20 for Y, I'm going backwards. If I'm multiplying to go forward, to go backwards, I'm dividing. I'm going to divide by 10. So 2 divided by 10 is 2 over 10. We always reduce every fraction, so 2 over 10 is the same as 1/5. 1/5 is my A value, and it goes into my equation to create the exponential. Number 4, we are not going backwards, we are going forwards to find the initial or a value. So I know I start with -1, 1/2, and end with 7, 1/28. So I am counting how many times I am multiplying by the growth factor. It looks like I am multiplying 8 times. 1, 2, 3, 4, 5, 6, 7, 8 times to get from -1 to 7. So I have 8 b values. If I have 8 b values, that represents this exponent. And now, because again, I do not have the real a value for my final explicit formula, I'm going to use 1/2 from the point I'm given. So starting at 1/2 and multiplying by the growth factor 8 times should get me 128. So I need to solve for b to the 8th power. I do that by multiplying both sides of the equation by 2. So now I have 256 equals b to the 8th power. Again, a factor tree. What number times itself 8 times equals 256? Well, that number is 2. If I keep doing a factor tree, you will see that I have 8 2's. So now when I take the 8th root of b to the 8th and the 8th root of 256, my b value is 2. And my growth factor is going to come from recreating the table. So now I am going forwards, multiplying by 2. -1 is a number less than 0, so that means I am adding numbers to x to get to the next x value. So from -1 to 0, I'm going forward. That means I'm multiplying by 2. So 2 is my growth factor, and -1 multiplied by 2 equals a growth factor of 1. That's my a value right here. Last two, I'm just going to show you the answers, and you can pause the video or stop the video, and you can see how I did it. The methodology was no different than what I did on page 18 or 1 through 4 on page 19. Here is the final equation for number 5, and here is the final equation for number 6. The only difference with number 6 is that, actually there's no difference. I thought it was a decay factor, but it's not, because to get from 1 over 100 to 1,000, I am multiplying by 10 5 times. So 10 is still a growth factor, and so my final equation is y equals 1 times 10 to the x power. So please use this page and page 18 to attempt your homework on page 21, and I'll see you next time. Bye.